Hello there, my name is Edera Mangwe from Kodarasa, and today we're going to look at SQL functions. So we've heard of terms like aggregate functions. I've covered them in a previous video, but let's look at them in a more in-depth way. So let's look at SQL functions. We have covered aggregate functions, so I won't do much on them, but they perform calculations on a set of values and return a single value. So examples are sum, count, mean, max, and average. I'll just run some of these. So give me a minimum of, so when I look at student, since we're using student for this, select all from student. So when I get the minimum first name, we can see G, Gata, and then there's that way. So Gata comes first. That's why it's the main value here. We can do the same account of all students. They're now 19. So we've looked at mean and we've looked at count. So let's look at another example. Select average number of students from activity. So when we look at the activity table, we do have ID, name, number of students, and performance. So an average of these will be the sum of everything divided by the number of activities, which is 6.5. That's basically your aggregate functions. The next one is the string functions. They manipulate text strings. They can be CONCAT, upper, lower, substring, trim, length, ASCII. There's so many. So you can look at the W3 School page on this. I'm going to attach it to the description. It has so many more that you can utilize to manipulate your strings, to play around with the strings. So let's work with some. Select CONCAT, first name, and then give it some space, and last name as full name from teacher. So I basically want to join and create a whole table called, a whole column called full name, and that's what we did from teacher. So we can see the first name and the last name are concatenated. You can also choose to convert something to uppercase. So everything is in uppercase. Similar to that, lowercase. You can take a substring. Maybe I just want a part of this string only. Don't give me the full thing. It may be for different, maybe a function just needs, or maybe to create a default username, you need to cut a piece of name. Like there can be so many uses. So in this case, strip, give me 1 to 3, and that's what it's doing here. Jo, che, mwe, muk, muk, and je, and you get the idea. So trim is another one. So trim basically removes spaces from the front and from the back. And we have left trim and right trim. Left from the left, right trim from the right. It won't be visible here because there were no spaces to begin with. Let me see. Select trim, and then I give it space. India. Let's see what this gives. It needs to have a column. I thought I would directly call it like that, but anyway, you get the idea. So give it a column and then remove that. So you can also get the length. If I'm getting the length of last name, so all the last names and the lengths. So those are some string functions. Let's continue. We have date and time. So obviously, they manipulate and retrieve information from date and time data types. We have different examples. We have current date, so fetch the current date. We have current time, returns the current time. Date difference, you give it two dates, and then it's going to give you the difference between the two. Date adds an interval, so you can be like add a year, add a month, yada yada yada. Here extracts the year from a date, month extracts the month, and of course date extract the date. Let's look at examples of this. So select current date. Current date is 2024/11/13. 13/11. So yeah, that's true. Select current time, does the same. You can see time and then the doesn't matter. So we have DATEDIFF, and this is the way to do it in SQL Server, but we're using Postgres, so that would be an issue. This is how you do it on Postgres, but if you're using MySQL Server, for instance, this is what you do. you give it the two dates and then use DATEDIFF function. But for our case, we get the date, cast it to date minus the other date, cast it to date as date difference. And we have 87. Here it's negative because the first date is like older. The first date comes earlier, so when you'll have a negative value. Select age. This one now gives the difference, except it's giving it in a more interval kind of way, instead of giving me just, because here we had all the dates, but I may need maybe something that makes more sense, like 87 days will have me computing how many months is this, and then how many days are there in, or years. So age in this case gives me a better difference, for lack of a better word. You can also now add intervals. As you can see here, we have a date, of course, cast it to date, plus interval of 10 days, plus interval of 2 months, plus interval of 1 year. So in the example here, when you added 10 days, we have 27 instead of 17. When we add a year, we have a whole year added, 2025. And notice how this column is named question mark, column question mark. You can change that by adding an alias. So another one we checked was extracting the year, give it a date. So this is the way to do it commonly in SQL, but not for Postgres. So how do you do it on Postgres? You use the function extract. Select extract year from, given the date, and then cast it to date as year, and then it will give you the year. And we're going to repeat the same. This will be this is an example that extracts our minute and second from a timestamp, from a datetime. So we have 15 hours, 30 minutes, and 0 seconds. We can extract the day of the week. Let's say I want to know what is it on Monday. Does this lie on a Monday, a Tuesday, or like depending on how you're counting your days of the week. You can check the settings for how your your Postgres stores the days, like when does it start. You can also check the settings for timestamp. You can check the settings for the datetime format. Is it starting? Is it year, month, date, like depending on your preferences. Are things you can set. I'll show you how to do that later on. You can also select day of the year. So we can see this is the 230th day of the year. So basically, you can extract the day of the week, you can extract the day of the year. So look at more of those functions under date and time and get to learn more about that and play around with them. We also have mathematical functions. We have things like absolute, which gets the absolute value of a number. So basically these perform numeric calculations on your data. So we have round, we have power, we have pi, we have ceiling, we have floor, we have absolute. I'm going to show you the examples. So I give it 3.142, round it to 2, it will give me 3.14. I give me the scale of 2.5. So basically the last integer you had, and floor the next integer you'll have. So here expect 3 and 2. For ceiling 3, for floor 2. Absolute of -5, -5 will be 5. Select power of 2 to power 4, 16. That's it on that. We have condition of functions. We have coalesce, we have null if, we have let's look at them. We have cast, we have convert. We already looked at convert, especially when we were doing dates, but let's look at more of that. And that's the exciting part where I even get to show you how to set some of the default settings, and you can even check what application you're using. Exciting. So let's look at some of these. Coalesce basically gets the first value that is not a null. So in this case, if duty ID is not provided, it will be 0. So we did have a case when it came to student, where 3 students had null for duty ID. So we gave it the value of 0. So another thing to note here is, of course, if I expect duty ID to be an int, even the value I give it for when it doesn't exist or when it's null should also be an int. I can't end up having a string here. Then, of course, I'll have an error. Inputs, invalid input for type integer. It expects an integer. So yeah. So what happens, like this is another example, null, null, 2 strings. It will give me winded, because that's the first null value. So what happens when you have all nulls? You get null. So that's coalesce. Let's look at another one, that is null if. So basically, this is if this value, for instance, if duty ID is equals to 1, make it null. That's what it's basically saying. So select duty ID, null if duty ID is equals to 1, then it's null. And then from student where duty ID is not null. So basically I added this part so that, because I do know there are cases where the duty ID is already null, but I only want it to convert to show me the nulls when it's 1. So we have null, null, null for every time the duty ID was 1. So if we didn't have that last where clause, we would still have nulls for now, even the normal nulls. So I was just trying to demonstrate that really. We have cast. I have 25.65 cast it to int, and it will convert it to the nearest int. Let's see what it does when it's 45. And we have 25. It converted it to the nearest int. So that's cast. It does convert it to the data type we've given it to. We saw it do the same. You can do it for different, let's say maybe I've given it a string and I want to convert it to a date, for instance. Then you can use something like cast in that case. We also have convert. It works similar to that, but it's not for Postgres, so I'm not going to run it. And then we have a way of doing that in Postgres, just like cast is using 2 colons and then the data type. And here we'll have 26, similar to what we have. Another function we can run is get the current user. Let's say I want within my application to know who's the user that the database is using. Maybe I'm trying to get that user so that I try to make a connection, something like that. Then you get to fetch the current user. We have this IIF. So this is similar to basically a case statement, but it can be used. If this, then do this. It's basically a shorthand case statement, or it's still an if-else statement, yes. So if this is true, yes, otherwise no. So I'm going to run the Postgres one, of course. Select case when 500 is less than 1,000, which is true, then yes, else no, and we have that as yes. That's for case. Let's look at another one. We have this numeric. This is not supported in Postgres. You can make your own custom functions. We're not going to cover custom functions here. We're going to cover it on its own module because it is a bigger topic on its own. But apart from these provided functions, you can also create your own functions that you can use in SQL. So you can use a custom function or a regular expression. So custom functions will come in when you're creating, we'll get to that. But yeah, so you can use maybe regex. In this case, this regex matches decimals, but maybe you didn't want to match decimals, then you can have an even shorter regex. So similar to current user, we can get the session user, basically the same user. This is interesting. Select session property and nulls. So I don't think this works on Postgres. Yes, but what's similar to that, which is the exciting part I was talking about, is so show standard conforming strings on. This just checks this specific condition, but it did bring a whole other topic. We were talking about session properties, and then we can get the different PG settings, like Postgres settings for your database. For instance, here I can get the value of client encoding, it's UTF-8. The date style, it's ISO, month, day, and year. You can convert that if you want. For instance, here I'm able to set it to day, month, and year. And when I come back, it will be day, month, and year. So that's how you research such things. You can view the search path. You can view the time zone. You can see here Africa, Kampala. And these are all the possible settings you can look at. So we have allow in place table spaces. We can even see, for instance, here the application name. So here I'm saying pgadmin. If I was, for instance, doing this same query, here we can see the application name is pgadmin. If I do this same query under PSQL, I need to see PSQL and not pgadmin. So let's look at that, run that, and when you look at application name, PSQL. So yeah, it works. Of course it worked. Anyway, so I can also now, system user is also not, it's a common SQL function, but it won't work on Postgres. As an alternative, you'll use the current user, the session user, and user on its own. So I'm not going to do that. I'm guessing this is also not, yeah, I have to cast it. So we've covered these sort of advanced functions, and last but not least, we're going to look at JSON functions. So of course, they allow you to work with JSON data types if the database supports JSON. So we have common ones. I basically have listed the common SQL functions, and then we can specifically go to Postgres. So you have a way to extracts data from a JSON object. We have JSON objects, creates a JSON object from key value pairs, and lastly creates a JSON array from values, that is JSON array. So let's look at that. We have an example here, JSON build object. So this does build a JSON object and calls it JSON data from teacher. So let's look at teacher first. Select all from teacher. And we have all these columns. So I want to build a JSON object with first name and level of education from teacher. So when I run this, I have first name, Joki, level of education, college, and the different teachers and the different levels of education. So that's how to use it. I can also, you can also convert it to use JSONB by basically, see here it will select JSON build object, but you can now also choose to use select JSONB build object. It will have the same output, but in this case you have better indexing and storage efficiency. So this is how to do it in other SQL. Like this won't work because it doesn't work on Postgres. But yeah, let me run it. As you can see, it's not recognized by pgadmin or by Postgres at large. So we've looked at build JSON object, like building a JSON object. Let's look at extracting a value from it. So we have select extract. So we select, so this is how we'd ideally be selecting on a normal at large SQL server. Like this is a common function, and then we'll go to the database. So this specific example works for MySQL. So it will be just an extract. We give it a column, and then we give the key value, and then from table. So that I'll show you how to do that in Postgres. We'll first create an actual JSON object. So anyway, let's look at JSON array. We've looked at how to create a JSON object from your values in your table. Now let's create a JSON array. This is how you do it on MySQL, and on Postgres you'd use JSON build array. So yeah, JSON build array, give it the arguments which are first name and level of education as JSON array from teacher. And back to where we were. Let's now look at the JSON object. So we're going to use this table here called employee. Refresh, and you can see, so employee has employee ID, it has name, it has profile, which is of type JSON-B, and manager ID. We already used this table when we're doing the soft join, so it's basically the same one. So insert into it values. So we need name, that is Kenya, profile, which is this JSON-B object here, and lastly manager ID, and we insert that. So for instance, when I fetch here, let me just do a select all from employee. I just have 5 records, so nothing much to write home about, but it was for the purpose of demonstration. You can see this JSON object here. Let me try and enlarge it. For some reason I can't seem to be able to do that, but here, so this expands it. Under profile we have employee as the key, and then a JSON object inside it, and then 2 keys, name and contact, name, and then contact, which contains yet another JSON object, and then with that key value pairs too. So let's do our extraction. As you can see, that's how we do it in MySQL. So let's do it in Postgres. So we use an arrow, which is basically a hyphen and a greater than sign. So when we use a hyphen and one greater than sign, it gets the value as JSON data. And when we use 2 greater than signs, it gives the value as text. So this is the example here. We have, as you can see, it's returned as JSON-B. It's a JSON value. The same query, except now we're using 2. We can see now the type here is text, so just something to check. So we have seen there was nesting involved. So what happens when I want to maybe fetch the name inside your employee? I'll do that. So similar to that, as you can see, the outer one had 1 greater than, and the inner one has 1 greater than, which means the inner value will be JSON in this case, and on the other hand, the inner value will be text. So anyway, that's how to extract text and JSON, and also work with nested queries. What if we want to map further? We can keep doing this, yes, but this is another way of doing it by using this function called JSON-B extract path. So coming back to this is what our profile looks like, and I want specifically the phone number. So that means I'll have to go through employee, then contact, and then phone. So I gave it the column name, which is profile, employee, contact, phone as phone number from public.employee, and that gets me just a phone number. So basically I was able to have that follow through, do that nested function. Let's see what would happen if I had done the same here. So contact and then phone. It does the same. So basically this is a different way of doing it. Whichever you find neater, pick and choose between the two. That's it on JSON functions. You can read more about these functions on this. I'm going to leave this page on the description. So we have different SQL Server functions. We have these are string functions: replace, replicate, reverse. You want to reverse a string? Extracts the number of characters from a string starting from right. So right, add string, remove trailing spaces from a string. Soundex. So look at them, play around with them. You'll probably need them, not as much in your career, but there will be a time, and you will remember to come back here. So welcome when you do. tan, you can get the tangent, you can get the cosine, all these. Yeah. So different parts of a date. Is it a date, like a check to check if something is a date or not? We've looked at date difference, date from parts. We saw something similar to that. Date name, yada yada yada. And advanced functions, we've looked at most of these. We've looked at session properties. We've looked at null if, it's numeric. So look at all these and play around with them. And last but not least, technically, I said I'm not going to cover this, but on a later video, we're going to look at how we can create our own custom SQL functions. And that's it on our video on SQL functions. I hope you learned quite a thing, and looking forward to seeing you on the next video. Bye.